Place a ruler on a sheet of white paper. You press the pen tip against the plastic edge, pull a straight line, and believe you have just begun from the first point. But look closely at the front of the ruler. Before the 0 mark, on many student rulers, office rulers, or wooden rulers, there is often a blank stretch. No number, no tick mark, nothing that seems to be doing any work. If a ruler is born to measure, why does it begin with a part that measures nothing at all? In design, this is dead space, a quiet gap before the numbers begin. But this silence is not useless. The 0 mark is like the starting line in a race. If the starting line shifts, every result behind it loses its meaning. The ruler does not begin at the edge. It begins where the number can still be trusted. Welcome to Everyday Things Explained. Today, we decode this small white space through durability, manufacturing, history, and human behavior. The ruler's edge is not trustworthy. By instinct, the outer edge of a ruler looks like the perfect starting point. But in real life, it is the least reliable part. Think of a ruler after a few months in a school bag. It falls onto tile floors, gets stuffed beside scissors, keys, and a compass. Over time, the outer edge can chip, wear down, bend, or become rounded. If the 0 mark sits right against that edge, every tiny bit of damage at the ruler's tip shifts the starting point of the measurement. In measurement, the distance between tick marks matters. But first, you must know where the reference point is. If you choose a damaged edge as the reference, the numbers behind it may look precise, but they still begin from the wrong place. So the blank space before 0 pulls the real measuring point back from the most dangerous zone, the ruler's own edge. The blank space is a sacrificial zone. That blank space is not extra. It is like a sacrificial zone. It can be scratched, chipped, or struck first. But as long as the 0 mark remains intact, the ruler still keeps a reliable starting point. In practical design, some parts are created not to do the main job, but to protect something more important. The foam inside a shipping box is not the item you bought, but it protects that item. The white space on a ruler works the same way. It absorbs the chaos so the 0 mark does not have to. That is why many common rulers do not let the scale begin right at the outer edge. Some technical rulers even have a clearer protective head, because in precision work, the measuring reference must remain stable for a long time. In other words, this blank space does not make the ruler less accurate. It gives the ruler a better chance to stay accurate for longer. The factory also needs a little forgiveness. There is another layer behind the ruler, the factory. And this is also where a historical piece of practicality is hidden. Before the 19th century, rulers were mostly made by hand by craftsmen. They had enough time and care to engrave the 0 mark right against the wooden edge. But when the Industrial Revolution arrived, everything changed. Tens of thousands of rulers began to be mass-produced every hour. A ruler looks simple, but it has to be molded, printed with marks, have its edges finished by a guillotine cutter, then packaged in bulk. In manufacturing, even good machines have small deviations. A cutting blade can drift very slightly. Ink and the cut edge do not always meet on one perfect line. If the 0 mark sits right at the edge, the factory must cut with extreme precision right beside the most important measuring reference. Just one tiny deviation can eat into the first mark. The blank space lets the process breathe. It is a concession from the history of engineering. If the cut line shifts a little, the error stays inside the blank zone. The 0 mark remains safe. This is forgiving design, not only for the ideal user, but also for real materials and the industry of mass production. Not every ruler plays by the same rules. Of course, not every measuring tool handles 0 the same way. Some specialized steel rulers have markings that begin very close to the edge. Because a craftsperson may need to measure inside a narrow groove, a machine corner, or a place where any setback would be inconvenient. In that case, the ruler's edge must be machined from material that is harder, straighter, and less easily damaged than a student's plastic ruler. A tape measure chooses a different solution. The metal hook at the end of the tape can wiggle slightly and slide a little. That small movement helps compensate for the thickness of the hook itself when you measure inside something or hook it around the outside edge of an object. 3 tools, 3 different methods, but all of them are solving the same problem: how to keep zero trustworthy in the real world. Zero is not where you think. Return to the ruler on the white sheet of paper. The blank space before zero no longer looks like dead space. It is a sacrificial zone for wear, a breathing gap for manufacturing, a tiny signal reminding you to place the reference correctly, and a shield protecting the most important point in every measurement, the beginning. The ruler does not begin at the edge. It begins where the number can be trusted. And if one small blank space can make a ruler more accurate, why is the hook at the end of a tape measure deliberately loose and clicking? As it turns out, the loosest thing in the toolbox is sometimes the most disciplined one. Thank you for watching Everyday Things Explained. See you in the next video.